All right, welcome back to SOC279. I'm going to do a brief demo in SPSS on how to get standard deviation and variance from SPSS as we started learning about this week. As you can see, I have a data set opened. It's a ANES 2012 data set. Right now, this is the data view, and if we were interested in it, we can go variable view. I'm going to start by opening a syntax file. And remember, I'm doing this so that I can just capture the different things that I'm doing when I do analysis, because I'm eventually going to copy all the codes into the syntax file, which will allow me to just highlight it and run it. So heading back to the Analyze window, we're going to go to Descriptive Statistics, and we're going to go to Descriptives. All right, so if you remember, in this window, we have variables listed as by their labels, and then if we right-click on it, we can list it by variable names. Okay, I'm also going to right-click and click on Sort Alphabetically. This will allow me to more quickly identify the variable I want to work with. So we're going to use the ft_t item. And if you remember, this is the item that asked respondents on the ANES, what are your feelings towards the Tea Party? And respondents were asked to rate those feelings from 0 to 100, where 100 was like they felt very positively or very warmly towards the Tea Party, and scores of 0 and low scores like 0 were indicating very cold feelings or very not great feelings towards the Tea Party. So we've highlighted this variable and then hit that little arrow button in the middle of the two columns, and that moves it over to the variable window. Now I'm going to also click the options here, and right now we're given the mean, the minimum, maximum, standard deviation. These are all the sort of default settings. I'm also going to ask for variance as well. So I just click all of those. If I decided I didn't want the minimum and maximum, I could just click those. But I do want it, so I'm going to click on both and go to continue. All right, so I've executed my command here. I'm going to grab this syntax by right-clicking on it and saying checking copy, and I'm going to go to the syntax editor. And in this window, I'm going to just copy and paste. Remember that when you do this, it'll also grab that get file and the path name. Like we talked about in class, what I would do is I would just ignore this front part, because one is that the file path right here is contingent on the machine that you're on, or in my case, I have a machine that has 4 USB drives. So if I, for one day I decide to put the USB drive in a different USB port, then I'm sorry, if I decide to put my USB thumb drive into a different USB drive on the machine, this will become a problem. It won't run because the data set, SPSS will look at it and think that it's not there. So what I'm going to do now is I'm just going to delete all of this for right now. And I'm going to comment, basically I'm going to make a little comment to myself, and I'm going to start that off with a star. So I'm going to say descriptive statistics including mean, variance, and standard deviation. Okay, so that is our code, and what this means is that we have this variable feeling thermometer Tea Party. There were 5,313 responses. The minimum score that a respondent could have scored on FT T was 0, and the maximum was 100. The mean or average score was 41.64. So if you figure that like right in the middle, you know, think about what this is in relation to the median. So in this case, the median is slightly higher than the mean, which tells me that there's likely some type of negative skew here, where more people felt relatively more negatively towards the Tea Party than those who felt positively. The standard deviation is 27.38, and remember what that means is one standard deviation. Let me see if I can find the whiteboard feature here. Let's go to the whiteboard. So in this case, if you had a normal distribution, forgive my drawing, I'm drawing with a mouse, and that's never well advised, okay? If you have your mean, you can then draw out 1 standard deviations, 2 standard deviations, 3 standard deviations, okay? And what you're saying with your standard deviation being equal to 27.38, why don't we just call that 27.4, is that you would add this 27.4 to the mean in order to get 1 standard deviation away. And then you would subtract it from the mean in order to get 1 standard deviation away below the mean. So if our mean was 41.6, okay, if we do a little math here, and I don't know if you can see this or not, I'm guessing you probably can't, but I'm just going to use a calculator on my machine. I'm going to add 41.6 to 27.4, that's 69. So this first standard deviation is going to be 69, okay? And then if we add that 27.4 again, we get 96.4. Okay, that's 2 standard deviations away. Okay, and 1 standard deviation below, we simply subtract 27.4 from the mean of 41.6. I'm going to do it over here on the calculator. So 41.6 minus 27.4. So that gives us 14.2 for 1 standard deviation below. And now we're going to subtract another 27.4. That'll give us a negative 13.2. All right, and remember, the first 1 standard deviation away from the mean of 41.6 is the range of that is 14.2 up to 69. That's going to include 68% of the responses in this data set. And then 95% of the responses will have a score for FT_T that is between negative 13.2 and 96.4. Now remember, this is really more of a theoretical exercise because it was not possible for the respondents to answer below a 0. So this isn't a really great example because it's the range here is restricted. But this is essentially what you would expect to see in a whenever you calculate variance or standard deviation. This is what a standard deviation is telling you, is that 68% of the observations are going to lie between 14.2 and 69, and 95% of the observations are going to lie between negative 13.2 and 96.4. All right, so let's see what else we're working with. I'm going to stop the share, clear all drawing. All right. And I'm just trying to see where I'm at here. Okay, so we're back to sharing the screen. And back to, what do you call it? SPSS. So that's how you do it. Remember, again, with variance, that if you square the standard deviation, so essentially multiply it by itself, you should get something similar to what you have in the variance column, okay? The other really elegant thing about this is that you could have chosen a bunch of other variables as well. So you could put in, so we used our example descriptives variables ft underscore t. You can choose other variables too, okay? So you could go ft underscore, what are some of the variables? I think feminist was one, and maybe ft underscore Obama. Let's see what happens. Okay, and so basically by including those additional variables, we're getting SPSS to basically give us all, you know, the mean, standard deviation, variance, min, and max for all of the variables involved. They're just stacked right up on top of each other. So in this case, we have a mean score of 51.19 for feelings towards feminists, 60.74 for feeling thermometer for the Democratic presidential candidate, and then standard deviation for both 23.87 and 34.61. So yeah, that's how you do that. It's pretty basic. If you run into any problems and feel like you could use a little help, you can always go up to topics, and that just basically launches a web page where you can either look on the SPSS documentation, or you can just Google. I love the Google. So we go Google SPSS variance standard deviation. In which case, we find a YouTube video that's much shorter than the video you've been listening to or watching, and then there's additional other resources that tell you how to get the things that you're trying to get. So that is that. I hope that you find this easy to use and useful, and that's all. See you next week. Bye.